So I'm just back from a visit where I had my opportunity to print with some SLS 3D printing, thanks to Sinterit. On that trip I also had a chance to make 2 interviews. One, which you will see very soon, is with Konrad, mechanical engineer, and it's very in-depth about the machine, and it's a little bit nerdy about technology and SLS and all. So if you're not into that at all, stop watching or just fast forward or just wait for the next videos, because this is a very long interview, but there's no way for me to cut it because that would be unresponsible and uneditorial or whatever it's called. So just be prepared that it's a long interview, but there's really interesting stuff in there. And I think that if there's any follow-up questions or anything that you find interesting or you want me to elaborate on, just drop a comment down below and I'll try to invite the Sinterit guys to answer any of your questions if I can't answer them. So enjoy the interview, just be prepared that it's pretty long, but it's very interesting as well. So keep watching. Would you like to introduce yourself and what role you have here at Sinterit?
Yeah, my name is Konrad and I'm a mechanical engineer here at Sinterit. I work in the department of R&D. I'm an employee here from March 2017, so it's about 7-8 months up till now. Yeah.
Talking about the Lisa system, it's the reason why I'm here, and it's I assume your proudest product as well.
Yeah.
So I'm just wondering if there's any particular features of the Lisa system that you are extra proud of? Maybe something that you have been really hands-on with?
I don't mean to brag, but I'm very proud of the entire system. So every mechanism, every component making the Lisa printer. And that is because most of the mechanisms were either designed by my coworkers back when I wasn't employed, or by me, so you know, I'm proud of it. But seriously, it is true that it's very difficult to pinpoint or to point just one component or one mechanism, because basically only together they integrate with the system and give you the possibility to print in the selective laser sintering technology. Yeah. So it's very difficult to pinpoint, but I think the best feature is the system that provides uniformity of temperature and also the temperature controlling system. This is something which our customers and users were very proud of, and also not proud of. They liked what we did, and they said that this is a great feature with respect to other SLS printers, yeah, SLS systems. Yeah.
Interesting. So, what are the challenges using exactly a laser with the selective sintering system? And using that laser, are there some obvious compromises or something that you have to think about to make it work?
Yeah, because the SLS system requires to heat up the powder in the printing chamber just beneath the melting temperature, the melting point. You need the laser, you need the additional energy to sinter the powder, and that's when the laser comes in. Yeah, so. Here at Sinterit, in the Lisa system, we use a 5 watts infrared laser, diode laser, and it's just enough to sinter our powders. In the case of different lasers, like high power or more powerful lasers, it depends. It depends because power is not, as we've discovered, power is not always the answer to the problem, to the questions. A while ago, we had done some tests regarding the capability of absorbing energy by not only our materials, but in some materials in general. And we discovered an interesting fact that power is one thing, but if the laser wavelength is not proper, some materials can reflect the energy back. Just refuse to accept that energy, and they won't sinter. And some materials say, okay, I will take the energy and I'll happily sinter with other particles. So the laser power is one thing, But sometimes the answer lies in the wavelength of the laser. So that limits the wavelength, and the power limits, of course, your capabilities of printing with different materials. I think, in theory, if we would have a higher power laser, we could, theoretically, we could sinter other plastics, glass, ceramics, metals, and so on. But there's the question, okay, what about the wavelength? That's something we would have to test. So,
yeah. All right.
So those are the challenges.
Yeah, because when it comes to SLS and using the temperatures, using the lasers, it's always a question about printing volume as well. Is there anything challenging to accomplish a bigger volume? Because everyone usually wants to print bigger with better resolution. So are there any, when it comes to SLS and with the Lisa system, anything that is complicated when it comes to large build volumes?
In fact, there is several problems or several aspects you need to think of. The first is as I said before, the uniformity of temperature and also the precise controlling of the temperature. That's one thing. No, the temperature, I think the temperature is the most obvious thing. Also, yeah, when it goes to the temperature, the inertia of temperature, so basically how fast the temperature will go from one point within the build volume, within the printing chamber, to the other one. Okay, so this is it. This is mainly the temperature. This is it. If you can have a uniformity, if you will have the correct temperature in every place of the chamber, then it's no problem. You can have a bigger volume, bigger workspace. But it's not that simple, as it turns out. You also have to ask yourself a question whether you want a bigger workspace, a bigger volume, your printing volume, because there are some consequences to that. The first thing is the system will get bigger, more complicated. But let's say for the user, it will get bigger. If it gets bigger, then it would get heavier. So a desktop printer would probably not be a desktop printer at all. And you'll have to think where to put it, either in your house, flat, apartment, company, and so on. There's also the problem of, with the bigger volume, printing volume, comes much more powder you need to sinter, or you have a bigger amount of unsintered powder, yeah? And there comes the problem of reusability, recycling, and so on. So you have a bigger batch of used powder. Also, the printing times would be much more. So maybe it's practical not to buy one bigger build volume, but buy more 2, 3, I don't know, printers that can work in parallel time and print maybe the same thing. Although, of course, there are some objects that you need to print in one as one component. So, yeah. Yeah, we'll probably think about expanding our build volume, but not in the nearest future. No.
Okay. So you talked a little bit before about lasers with the strength and everything, and I think that's interesting for a lot of people trying to understand it. And as you gave an example also among some possible materials, as I said, for example, glass or metals, in theory, with another laser and another wavelength, or more precise wavelength.
Yeah.
Are there any, with the system that you have today, even if is it in theory, should it be able to run other types of powder from other manufacturers? In theory, it's...
In theory, yes, in theory. In theory, yes, and as much as I can say, yes, we can print with different materials, different powder materials. We had some very successful tests, but that's all I can say because I can't name the powders. and you'll just have to wait until Sinterit will be ready to reveal that information. I'm sorry. I will tease you a little bit and the viewers, so yeah.
That's exciting. Yeah. So it's also, by using the materials, I think it's a common misunderstanding on how you can reuse the materials and in what form they are reused, and maybe why you can't reuse them. So I think people understand or believe that it's very difficult. Could you explain a little bit why it might be this difficult? What are the challenges in reusing material, and how you're solving it with the Lisa system?
Yeah. The first, I think, common mistake is that not every material has to be recycled in a way that you have to provide a batch of fresh powder. Some materials, for instance, our material, the Flexa Black material, it's based on the thermoplastic polyurethane, is 100% reusable with no batch, no mixing. It has the same properties before sintering and after the print, after being sintered, or at least our tests show that there is no differences. So in the case of the Flexa Black, it's okay, you don't have to worry about it. In the case of polyamide powders, nylon-based powders, like for instance our PA12 Smooth, the problem is with aging mechanisms, aging problems, aging phenomena. Let's imagine for a second a small particle of the PA12 powder. In the build chamber, the printing chamber, all those particles need to be heated up to a certain temperature. It's just beneath the melting temperature, and the laser, has the lacking energy needed to sinter it. But the unsintered powder, because it's heated up, it has an enormous amount of energy from a chemical or physical point of view, and it's linking with the oxygen that is floating, the oxygen particles that are flowing all around the build chamber and also our environment. Yeah, oxygen is everywhere. And when they link together, the particles of the PA12 and the oxygen, you have a compound that is very hard to sinter. It's not impossible, but it's very hard to sinter. And to have it reusable again, we need to mix another batch of fresh powder. Most manufacturers or most companies says it should be like the volume plus 50% of a fresh powder volume, okay? In case of our PA12 powder, we suggest it should be only 30%. So I think that's nice for a beginning of our journey. Yeah, so that's it. We also have some other solutions to that problem, but we are still testing it, and it takes time. It's a steady pace, but yeah, we are working on it.
Yeah. Okay, so what would happen if you used more of the recycled material than recommended, which means that for the PA12 you don't add any new material? What could be the side effects of that?
So there are some consequences, okay? First of all, the material would be less resistant to tensile strain, to bending. It would be also porous, and also it would be, let's say, it would have a shade of brownness to it, okay? So it's not recommended. Yeah. If you want to have an inferior model, okay, an inferior print, okay, that's your choice. Maybe it will be good enough. But if you want to have a quality one, you need to stick to the rules that the manufacturers or the companies give you. Okay, 50%, 50%, 30%, 50%. No, okay, no, that's enough. So basically, that's what will happen.
It's also good that it turns a little bit shade of brown. That makes it easier for your support guys to say, maybe you should reuse a little bit more.
Yeah. We just miscalculated. Yeah, okay.
That's good.
Also for the user, okay, if mixed up too little of the fresh batch, okay, we have to put in a little more. Yeah. So, yeah, maybe it is a nice feature.
Do you see any improvements or extra solutions that could reuse the or increase the reusability? You mentioned something before and teasing it a little bit, but would it be maybe some sort of extra product or maybe something in the machine?
No. I think it should be implemented in the machine, but in such a way that any of our customer who buy the system before and would buy it later on will have the possibility to upgrade the machine. Okay. That's our goal. We don't want to face our customers with a dilemma. Okay, we bought the Lisa 1 system, okay, and now we will have to buy maybe a different system or a subsystem. Well, subsystem is okay if you can link it with the Lisa 1. If not, I think that would be not fair.
Yeah, I think it's very nice approach to it.
Yeah.
So the powder feeding mechanism is something that I always wondered how you solve. I assume it's very crucial to make sure that the new layer, especially when you print with these small layer resolutions, it's very crucial that you are covering the whole area, that there are no marks or no scratches in the new layer of the powder. Yeah. Could you tell me a little bit how that feature is done and how you can ensure that it's doing it every time?
Yeah, so the question is basically how our mechanism works and also how it's built. How it's built. Okay, I think I can answer this question. Imagine two chambers. The chamber on your left, let's say, is a chamber that stores powder just before printing. So let's say it's a fresh or a mix, powder. And you have the right chamber, which is basically the printing one, okay, the place that the sintering comes to life. You also have pistons, okay, so a mechanism that basically controls what is the volume of the one chamber and the other chamber. At first, the feed chamber, the chamber with the powder, unsintered powder, is of course the large, okay? So the piston is low, on its low position. On the printing chamber, the piston is up at the maximal position. But you need a device that is basically going to put powder from one chamber into another, and as you said, make a proper distribution of powder and make the layer looking correct and be correct. And that's where the recoaters mechanism plays along. We call it the recoater. And it's a very crucial and very complicated device because on one hand, it has to make certain movements, synchronized movements. The first movement is a linear one that is sweeping the material, the powder, from one chamber to the other chamber, but that is enough. It's sort of like a razor, let's say, okay, but that's enough, but that's not enough. The razor can misplace the powder and so on and so on. So we do not use the razor, the sharp, let's say, edge for the recoater. We use a shaft that has another rotary movement to it. So the mechanism has to go in linear way and also the rotary one. But the rotary one is not the kind that you have when a car, let's say, is moving. Okay, the car is moving linearly, and the wheels are moving in a, let's say, clockwise.
So it's rolling with the motion.
Yeah. Okay. Yes, it's rolling with. In the case of the recoater, it's not rotating with the but counter to the linear movement. Yeah, and it's very complicated to synchronize those two movements because you can't have the linear movement too fast or too slow with comparison to the rotary one. So that's That's very challenging. But also the conditions in which the recoater works, and those hard conditions are high temperature gradients, okay, so not only a high constant temperature, but the gradients, okay, so the fluctuations, and also the dust, yeah, from the powder and so on, and that basically makes it difficult to make the recoater from sophisticated elements like bearings and so on, okay? You have to use very robust and thus very primitive, let's say, elements. So that's challenging. To have a very complicated mechanism done or assembled from very primitive, let's say, parts. So this is very challenging. But let's get back to how it works. So basically, the recoater is sweeping the powder from the feed bed to feed chamber to the printing chamber, and the rotary movement of the shaft that is mounted in the recoater is simply pushing the powder and making it smooth and nice and with the thickness that we want. Also, the thickness is intertwined with the step of the piston from the chambers. And I think that is no secret that we use stepper motors, very precise one, in the micro-stepping controlling system. And the movement is basically done by changing the screw, rotating the screw to a bolt that is constrained in such a way that it can only move up and down. And this is basically the secret to the Lisa system.
Okay. Yeah.
Oh no, I've said too much.
All right. So the health and safety aspect of a SLS machine is something that people are wondering about. It could be some miscommunications and something that is not valid for when it comes to like metal and polyamide, that you need to have masks and gloves in a really sterile environment. Yeah. What are the guidelines for your users, and what can you tell about the whole questioning about the safety?
Yeah, so when it comes to protective gear, so of course we recommend to use safety glasses, we recommend to use a normal mask, and also gloves, okay, because the PE12, because this is basically the nylon-based powders or the polyamide ones, they are not toxic. They are not toxic, so even if you have powders on your hands or even on your face and hair and so on, it's not toxic. The other thing is with the shape of the powder. When you have metal powders, the shape is like a needle, let's say. It can stick to your skin. It can also curl down to your breathing apparatus or your lungs and so on, and stay there. And this is unacceptable. Also, the ceramics is the same thing, and glass also. That is why the glass composites. Yeah, I think composites. Yes, this is what it is called. Are very dangerous and should be handled with care, with the gloves and so on, the protective gear. In case of the plastic powders, the nylon powders, they are in the shape of a sphere. So they are not. They can't stick to anything. More or less, if they get to your nose, yeah, or mouth, you can simply sneeze it out, or simply drink some water and yeah, have your mouth cleaned. So yeah, they have no cancer properties and so on. At least none of the manufacturers say that it has cancer features, and also all sorts of tests don't show any cancer properties. So so there shouldn't be a problem. With the TPU, I mean the thermoplastic polyurethane. Okay, well, this is a rubber, so there should be a protective gear, the glasses and so on. So just to be safe, but it's not toxic, and also when it goes to the dustiness, okay, the environment in which it should, the printer is, you can put it in your flat, yeah, maybe even on the desktop, and just clean it once in a while, okay? It's not that dusty, I think. You had a first-hand experience with the printer, and I think it isn't that messy. But you know, if you wouldn't clean it up in once a week or so on, okay, there are gonna be problems. But basically, if you are not tidying up your house and your room once a week,
then it's dirty anyways. So
yeah, it's the same thing.
Yeah.
So I think it's completely safe, and the dustiness is not a problem. And if you have a company that has, I don't know, 10, 12, 30 Lisa systems or any other SLS systems, and they are all working on a huge factory, I think the dustiness is also no problem for you. So.
And it's also, correct me if I'm wrong, but it's also quite heavy, so it shouldn't like go around a lot in the air. It's going to sink down to flat surfaces, which means that it's easier to clean. And also, it's not that light that it goes in the airways, maybe. Yeah, and also the system, the Lisa system, is isolated well enough, so the powder won't just come out and So SLS printers, as we know, and as well, if you don't know, you should check out some of the videos where I talk about it. But SLS printers are well known to be able to allow you to make very complex models, which means that I think one of the most powerful examples is that you don't have to think about volume. So you can print, we had an example, if you want to print a model railway, even if the build volume is limited in X and Y, you have the Z to play with. So you can print let's say a 90mm part. You can print bigger, of course, but a 90mm part, but you can make 10 of them or even more, 20 of them in height. So you can print a lot of things with the same volume overnight. So with these complex models, you also have to think a little bit more, because another example is that you can do moving parts. You can have a wheel axle, and you have a small distance between the axle and the holder. Are there any features in the current software that helps you identify anything that is too small? If you design a model that has some gaps and you want to ensure movement, are there any either design recommendations or any features that warns you?
The software that we use, the Sinterit Studio, displays an information to the user when some models, but different models, intertwine with each other or have a collision somewhere, and so on and so on. So we are informing the user, okay, there's a collision here. I don't think our software intertwines them, but just cautiously informs the user that there's a collision here. Do you want to do something with it or not? Okay, so this is one of the features. The other feature, unfortunately, that would communicate about too narrow thickness or too narrow space gap between movable parts. That is something I must say we didn't think about. Yeah, we thought, the user, when he is designing his objects, he has a little bit of knowledge about what can and can't be done, okay, from an engineer even perspective. But now when I think about it, there are also users that are non-engineers, okay, artists and so on and so on. So the feature with informing the user that the thickness is too small or it's too big, we can't inform about that because that's your choice. But the thickness, that should be something that we should communicate, and that's a fantastic thing. That's yes, we should work on implementing something like that. Yeah,
great, because I think that, just having some sort of design guidelines would help people understand what's possible and what's not. And when you're getting closer to things that are harder to do, because everything is not black and white. either you can't do it or not. There are of course some gray zones.
Yeah.
And when users get close to them, it would be great to have materials to just watch. And I think there's already some material available, but yeah, it's interesting to see the software development as well.
Yeah.
And so also speaking about software and about the reusability, printing flat models or models really tightly packed would minimize both printing time and the unused powder, will help with the powder management. Are there any stacking mechanism in the software, any features that help optimize how the objects are saying? I think you just answered that question a little bit with the collision and that it doesn't untwine things. Yeah. But are there any other features that help with making the build more efficient?
No, unfortunately, you caught us by surprise, and we don't have a feature like this by now till now. But as we speak, and this is something that is very funny to me, because as we speak, 2 rooms down the corridor, there are the programmers that are just working on that exact thing, on the nesting. The nesting feature or that kind of features. So it's funny, but no, we up till now we don't have that feature, but the programmers are just working on that feature. Okay, so I don't know how long it will take for them, but it can't be that difficult, I think.
You have to bring them some coffee, and we can have it soon.
Yeah.
All right.
Or just lock them up.
That's another way as well.
Do it.
All right, so just finishing off about SLS, which I think is a really interesting technology and also quite unknown among other ones. Is there anything that you feel is the most speaking feature for you, or the best feature of SLS 3D printing?
I think I won't be a very creative person, I will say, because I think the most important feature for anybody, for engineers, for artists, different users, would be we call it the freedom of form. So basically the SLS system can provide you with possibilities of printing different geometries, okay? You want an engineer, for example, you want movable mechanism, a kinematic structure, or just a complicated element but with certain tolerances. Here you go. You don't have supports, so you don't have to remove them. You don't have to clean up the surfaces from the supports. And by that you also can achieve cylindrical shapes. And with the supports, you will have something like elliptic ones. Yeah. Here you can have a simple cylinder, not an elliptic one. So that's for the engineers. For artists, some artists has to cope with the problem that their artistic vision, is limited by the means of doing sculptures, let's say, or any other objects. With SLS, no problem. What you think, the limit is your imagination, basically. Yeah, let's say.
Yeah, that's great.
So the artist is a second group of users. So yeah, the freedom of form. That which is, I think, still impossible to for the FDM and SLA systems, because they have supports. I will brag and say it's not a challenge for an SLS system. Okay.
There were one example, I can't show it because of a license, but I can probably talk about it. There was a heart with a lot of, that was generated from a CT scan.
Yes.
And in a normal situation, that would be a lot of work taking that mesh, trying to orientate and print it and have it displayed. But the ability to as I say, freedom of form, is that you can just take that volume that you want to print and you print it, and everything that, well, hopefully in your body the blood veins are attached, so when you print them it's attached.
Yes.
But you don't have to think about anything when it comes to support or volumes. You can even have the heart chambers if you want to have, everything can be printed. And
yes.
that for me is a really interesting example where doctors can visualize
yes.
operations before by just having a model in their hand. So it's really interesting that you say freedom of form.
And the model can also be cut in different ways, okay? So that it is in one object, but if you want, you can also have it cut in 4 or 5 and see the things normally from the outer side. You can't see, okay? Just in the inside. And also if it goes to a heart, I was printing a heart a few years later on the FDM for the surgeons, and I remember they were very excited that the veins from the heart, the small veins, they are called. They have a sophisticated name, but I can't remember. But they were very pleased that small veins also are present on the FDM object. But I knew that no, it's just the FDM filament just stick here and stick. This is not, sorry, and I told them, okay, this is not how it looks. The heart, the chambers of the heart and so on, it's okay. But the veins, no. Here you can have all the veins going to and from your heart. So this is extremely useful, okay, because this is 100% exact. So yeah.
Last question. So, if there is anything you could add to the Lisa, and this could be totally imaginary, it doesn't have to be something that's bad or something that you feel like, just anything. If you could add any feature at all to the Lisa, what would that be?
We were once thinking about a popcorn feature. To make popcorn, okay, if we have the temperature, okay, no problem, okay, you are waiting for the print to build, to center, okay, you can also have a popcorn, yeah, so it's no problem. You also have the powder, okay, not to solve the popcorn, just with the powder, the PA12, that would be nice. Also, we thought about instant dyeing, not dyeing like death, but dyeing like coloring the prints, yeah. So we thought also about that, but in all seriousness, I think we would very much like to introduce the system that would help to reuse much more of the powders. We are working on it, but sorry, I can't say anything more because my bosses would maybe not kill me, but fire me from work.
You'll be locked in somewhere.
Yes. So yeah, that would be the feature I would want to see, but I can't talk about it, so it's pointless basically.
But that's good. That means that you're working with exciting stuff that you want to have, and you're really ambitious to get it done. That's super nice.
We are all fanatics in a way. Well, fanatics is maybe not a good word, especially in our times, okay? But yeah, we are working with passion. We are a passionate group, a passionate people, and yeah, I think from passion can come great things. So yeah.
Okay, very nice.
Thank you. Thank you for the interview. Thank you.
It was great.